Uh, See, gentlemen, in the last class we discussed about the Ohm's law. While studying Ohm's law, we have studied the relation between current and potential difference at constant temperature. Based on that outline, we can able to design the statement of the Ohm's law. The statement says that strength of electric current flowing through the conductor is directly proportional to the potential difference provided temperature and other physical conditions remains constant. So that means that according to Ohm's law, I can write it in mathematically, I is directly proportional to V at constant T. At constant T and other physical condition constant. So this expression can also be written as V is directly proportional to I. Or we can say that this expression is associated with the proportionality symbol. So therefore you have to eliminate it. V is equal to I into R, where R is the resistance of electrical resistance. So the question is that what is the electrical resistance? So opposition offered by the conductor for the flow of charges, which is known as the electrical resistance. So it is a property of the conductor. It is a property of the conductor, or it is the nature of the conductor. You see that on analyzing Ohm's law, we see that V is equal to I into R. R we can write it as IR is equal to V. R we can write it as R is equal to V upon I. This form also we can write that Ohm's law. This form very useful in order to define the resistance. So electrical resistance of the conductor is the ratio of potential difference across the ends of the conductor to the current passing through the conductor. So you may ask that what is the definition of the electrical resistance? It is nothing but the ratio of potential difference to the electric current passing through the conductor. So you know that so what is the SI unit of electrical resistance? SI unit of R is ohm. So ohm is the unit of electrical resistance, is it? So now let us see, like to discuss about as I said it, the resistance of the conductor that depends on the nature of the material. It also depends on the dimension of the conductor. So majority of people we are not aware of it, how the dimension plays in varying the resistance of the conductor. In order to study the role of the dimension in the resistance of the conductor while calculating the resistance of the conductor, so we have to draw this figure. With this figure, we can able to study what is the role of the dimension. So here, in order to understand the concept of the, in order to understand the role of the dimension while studying the resistance, you have to draw this figure. This figure, we can able to clearly understand that how the resistance related with the dimension. Dimensions, first of all, you have to know what is the meaning of the dimension. Dimension means it may be conductor's length, breadth, or volume. So all together we are calling that dimension. All together we are calling that dimension of the conductor. So first of all, so we have to study how the length, if a length of the conductor increases, whether the resistance of the conductor increases or decreases, what is the relation between resistance and length of the conductor. As usual, you are already familiar that in the old syllabus we are studying that resistance of the conductor is directly proportional to the length. I mean that factor which is affecting the resistance of the conductor, so at constant temperature. So R is directly proportional to L, where L is the where L is the length, L is the length, and R is inversely proportional to cross-sectional area, where A is the cross-section area, cross-sectional area, cross-sectional area. So you know that these are the two factors are there. One is the R is directly proportional to length, second is R is inversely proportional to cross-sectional area. What do you mean that? So it means that as the length of the conductor increases, resistance is also increases. As the length decreases, resistance will be decreases. So that means that resistance of the conductor solely depends on the length of the conductor. So now second case is that the second factor is that so resistance of the conductor is inversely proportional to the cross sectional area. As the area increases, resistance will be decreases. So area decreases, resistance will be increases. So this is the what the theory we have already studied. Now let us see on clubbing equation 1 and 2. Clubbing, I mean that combining equation 1 and 2, 1 and 2, you will get R is directly proportional to L and inversely proportional to cross-sectional area, which can also, since this expression is associated with what proportionality symbol, you can write it is R is equal to rho L upon A, where rho represents the resistivity of the material, where rho is the specific resistance or resistivity of the material. So resistivity of the material, so it is the nature of material. Resistivity depends on the nature of material. It doesn't depends on the its value do not depends on the what dimension of the conductor or dimension of the material. So SI unit of resistivity, so SI unit of rho, so which is nothing but the is ohm meter. So the question, majority of the students they will make mistakes while writing the unit of resistivity. See, in order to write the unit of resistivity, you have to consider this expression. This expression rho is equal to RA upon L. So you know that dimension of the resistance is, unit of resistance is ohm. The unit of cross-sectional area is square meter. Is it? Unit of length is meter. This cancel. So ultimately we will get that ohm meter. This is the SI unit of resistivity. So now let us see. We would like to discuss about the what is the definition of the resistivity. So in order to design the definition of resistivity, so once again you have to consider that above expression rho is equal to RA upon L. So you see that you have to prove that in order to prove that to show rho is equal to R, this is possible only if A is equal to 1 square meter and L is equal to 1 meter. And in this case only you can able to prove that rho is equal to R. So in order to prove that rho is equal to r, just you have to substitute that these values in this equation. Say rho is equal to r, a is equal to 1 square meter, is it? L is equal to 1, so 1. So ultimately you will get that rho is equal to r. So based on this outline, I can able to design the definition of the resistivity. Resistivity of what? Resistivity of a material is approximately equal to resistance of that material having unit length and unit cross sectional area. This is what the precise definition of the resistivity. So majority of the students just they are giving the importance for the mugging the or the definitions. Instead of mugging the definitions, preferably they have to try to analyze the or based on mathematical expression, try to design the definition of the resistivity. Resistivity of a material is numerically equal to resistance of that conductor having having 1 meter length and 1 square meter cross sectional area. In other words, so you can say that resistivity of a material. Resistivity sometimes it is also referred as the specific resistance. Specific resistance of a what? Material, which is equal to resistance of opposite faces of cube. So this is a cube, for cube all sides are equal. You can say that you have to consider the opposite sides of the cube. So you have to measure the resistance of the opposite sides of the cube, which gives the resistance. This resistance approximately equal to resistivity of the material. So far we have discussed about that specific resistivity theory. So according to that, that is resistivity of a material at constant temperature is directly proportional to, that resistance of a material directly proportional to length, and resistance of material is inversely proportional to cross sectional area. So these are the two factors, is it? These two factor, on combining these two factor equation 1 and 2, you will get this type of expression. Since this expression is associated with proportionality symbol, you have to eliminate it. In order to eliminate it, you have to take a constant of proportionality where r is equal to rho L upon A. So the R is the resistivity of a material. So SI unit of resistivity is ohm meter. So see that rho is equal to RA upon L. So in order to define the definition of resistivity, as I said it, so you have to treat that, you have to prove that rho is equal to R. In order to show rho is equal to R, so you have to treat that A should be 1 square meter or 1 unit length or unit length and one square meter area. So under this case, you can show that rho is equal to R. So in addition to that, as I shown that how to obtain the SI unit of resistivity. So in order to obtain the SI unit of resistivity, we will consider that this expression. So the SI unit of resistance is, as you know, that ohm. The SI unit of area is square meter. The SI unit of length is meter, get cancelled. Finally, we will get that rho is equal to ohm meter. Majority of the students, what they are committing mistake, rho is equal to ohm per meter. This is wrong. So therefore, try to this is what the theory. So in order to, this is the what the old version. This is the what the old version of the how to find the relation of the resistivity. Nowadays the trend is going on in NCRT. So according to the NCRT, so see, you have to consider a conductor of slab of length L, is it? So this is a conductor, you can